Bicycle seat angle is a common concern among performance level cyclists. Reason for it is your performance is directly related to the bicycle's geometry, part of which is this seat angle. So every time you change seat from one model to a different model, this seat angle needs to be set accurately to the number that works with your pelvis and your drop. The drop meaning the top of the seat height here to the top of the handlebar there at the stem post. So depending on the bicycle's geometry, your performance is related to it, and you need this number that the seat geometry and everything, the bicycle's whole geometry, can be accurately duplicated once you swap seats. So in this video I'll show you a number of ways how to accurately determine the seat angle from the horizontal there. Essentially we're doing trigonometry, looking like this. This triangle would be representing here the top of the triangle is the horizontal there, so this is the triangle and this is the angle here that we're trying to determine. I hope this makes sense. Trigonometry. So let's get started. So for these measurements the bicycle is plumb both ways. Fore and aft it needs to be level, as well as side to side it also needs to be level. So the front wheel there is clamped in, it's not moving, and we can begin measurements. One instrument that is here for the concept is this level, this water level. Inside is green water in a vial and there's an air bubble in it. When the instrument is horizontal, then the bubble stays between those two black lines like so, and this way it's out of level. It's only here for concept, because when you put it on it, all you can conclude is that the seat is out of level. Not really helpful in duplicating its exact geometric position, but it's just here for concept. So one instrument that's somewhat inexpensive is this angle gauge. You can get it at a hardware store, and when the base is horizontal, the needle points at 0 degrees. You can put it on a seat and get a quick reading, you're done. It is pointing at something like 12, 13 degrees, something like that. There, the needle is thick, the measurement lines or the lines on the instrument are quite thin or narrow, so it's difficult to get an exact angle. Plus there is one more problem with it. Often the seat cushioning is uneven in the seat when the seat is unloaded like this, and the short base of this instrument might be riding on one of those bumps and going into a valley, something like that, so it could be a little bit off a degree or two, whatever. So it's going to be a little bit inconsistent because of its short base. You can put it on a longer piece of straight wood and on top of it put the instrument. That solves the problem. So this is one way of doing it. Another item from the hardware store is a speed square, very common cast aluminum speed square, and this one has some angles on it. You can see here 0, 5, 10, 45 and 80, 85, 90 degrees. So how does this work? Fairly straightforward. Put it on the seat like so, and this immediately solves the problem. You can kind of see the air underneath the foam cushioning there. So it does need a plumb bob. A plumb bob is just a string line with tie a bolt or a nut or something to it and use the string portion of it. Don't worry about whatever weight is hanging on this thing. How this works is fairly straightforward. Here where it says pivot, this is where the string line goes, like so. And just hang the plumb bob there and take a reading where the string line is in front of the number scale there. Now there's a problem with this. This speed square needs to be tilted in order to take a measurement, because this plumb bob is hitting the seat post here, or the light or the whatever. It's gonna hit the seat post or the frame here. So it's if you tilt it in, then the string line is going to be I don't know, 2 centimeters away from the scale where the numbers are. And if you look at it a little bit from the left, it's going to be a different reading. If you look at it from a little bit of right, it's going to be off on account of that. However, you can, if you carefully adjust it and whatever, and you can still estimate that this string line is crossing between the numbers 55 and 60. So you can reasonably say that this is vertical here when it goes through the 45. This is how the numbers work on the speed square. So you can go 5, 10, about 12, 13 degrees, something like that is the seat angle. So that's speed square. What if you don't have a speed square? You might have one of these rulers. This is a square. A square is also riding over the uneven surfaces or seat cushioning on the seat, and the good thing about it is you can extend it to the back here, and you can hang your plumb bob here where it's freely hanging and is not hitting anything, seat post or anything. So this is the great thing about the square. Just pick a corner here on the short side, something like that, however long it is, whatever. And the good thing is it's got numbers on it, so just whatever numbers are there, take a reading, and whatever numbers the string line is crossing directly, you can put the string line right on the number line here, and you can take a reading there on it. Very straightforward. Once you have one number and another number, I'll show you what to do with a calculator. Very straightforward. The least expensive and most accurate is this piece of paper. This is poster board, you can cardboard, whatever. And I made a mark on it using a ruler and of course pencil. So how this works is essentially the same as the previous system, just if you don't have the square, don't worry about it. This is also a solution here. So I made a mark here on this paper here indicated by this arrow, and this it's a 200 millimeters. Why 200? Why not? It's a convenient number. It's a round number. I didn't want to pick 157.5. Okay, so I just wanted a nice 100, 200, something like that, and just measured out from the corner. Now this corner here is assumed, it comes from the factory this way, assumed to be square. What I do is exactly the same as what I've done with the previous square. Put the paper on it like so. From this mark, which is at 200, is a known mark. Now there, this is where I have my string line held, right about there. So I just take it to the seat here, and needs a little coordination here, and maybe give it a little more string line. Thereabouts, you get the idea. The string line is crossing the paper at one point. Mark this location. I have already marked it. It's there. So what we essentially have is a right angle triangle that looks like this. One side is 200 and the other side is, in this case, 47. What you do with the 200 and the 47 is this: enter it into the calculator like this. Second function tangent with a bracket. Let's see what happens. So, calculator. Make sure it's in degrees, because otherwise it's going to be off and you're going to be sorry and miserable. And yeah, it can toggle to radians and gradients, so make sure it's in degrees, DEG. So what you do is, on this model, second function tangent, open a bracket, 47. You can use the ABC button, or you can use this division button, either which way, between the 47 and the 200. There, close the bracket, equals, I guess it's 13.22 degrees. Problem solved. So that's my seat angle, and once this number is recorded somewhere, I don't know, you can write it on the frame, on your seat post, whatever, somewhere. You can write it on the underside of the seat, such as I have some data on the underside of the seat here. This one says 230 grams, but I'm also going to record on it this 13-degree angle, although the different models of seats need slightly different angles. So this one with the super thin cushioning worked at 10 degrees. This one with a little bit more padding on it, and as I sit on it, the foam compresses slightly differently, needs to be at 13 degrees. But you can record this on the underside of the seat, that this works at 13 degrees and this works at 10 degrees. And there you have it. So this would be this would be the least expensive way to measure it, and it really doesn't need anything, just calculator, ruler, pencil, piece of string, and a bolt. So there you have it. Thank you for watching.